Hello, this video is for the subject of electricity. This video will cover the material for the electrical part of the West Virginia Mine Foreman test. The format for the video is question and answer. And this video will also reference the question and answer to the West Virginia Office of Miner Cell Safety and Training Mine Foreman Study Guide, and that will be the 2019 edition. And these questions are in the electricity part of the study guide. So question number 1, define a grounding conductor. And the answer is a grounding conductor, a safety ground or a frame ground, is a metal conductor that connects metal frames or enclosures to an effective grounding medium. So all of our equipment has to be grounded to a very good ground. So if the equipment will become energized, if there would be an electrical phase of electricity gets against the frame, if you would walk up and touch that, you could get electrocuted. But since we have this ground wire, then that electricity could flow through the ground wire and would kick the breaker. I think it's safe to say that you don't have to have a ground wire for electrical circuits to work, but we have to have a ground wire for them to work safely. So we have things built into our systems to make us have to have a ground wire for it to be safe. Number 2, define permissible. The answer is any equipment or device that has been approved by MSHA and or the U.S. Bureau of Mines. This equipment is designed to meet the guidelines of MSHA and the Bureau of Mines. So permissible equipment means that you can run it in areas of a mine that could have methane gas, coal dust mixtures, and if it's maintained properly, it will be safe to run in these explosive environments. Of course, we don't want to run it in an explosive environment. We're going to de-energize the power at 1% methane. Number 3, who approves changes made to permissible equipment? And the answer is the director of the West Virginia Office of Miner Cell Safety and Training. So this can be a little bit confusing. So who approves the equipment to be permissible originally is MSHA. But if you want to change a piece of permissible equipment, you would have to get approval from the West Virginia Office of Miner Cell Safety and Training. 4, what's a branch circuit? And the answer is any circuit that is connected to and leading from the main power lines. This could be a direct current or alternating current. So here's a little picture I have. You can maybe see my mouse pointer. So we have the main power line going underground. And in our mine, it will branch off and go to different sections or different areas of the mine. And where that branches off, that will be known as a branch circuit. Number 5, what is low voltage? And the answer is voltage is from 0 to 660 volts, and this does include 660 volts. So you have low voltage equipment at your mine. What comes to mind is roof bolters and shuttle cars are typically either 480 volts or 575, but both of them are less than 660, so their low voltage equipment may be chargers, scoop battery chargers are usually 480 or 575, so that's low voltage. Question 6, what is medium voltage? And that's the answer is voltage is from 661 to 1000 volts. So medium voltage equipment that comes to mind is continuous miners. Most of them are 995 volts. Some of your coal feeders may be 995 volts, but that's medium voltage equipment. Number 7, what is high voltage? And that's voltages more than 1000 volts. So anything more than 1000 is high voltage. And the voltages, common voltages that we have at the mine are 480, 575, 995, 2400, 4160, 7200. So we have classes of voltages in those increments that I just mentioned. So high voltage is going to be 2400 volts is I think the first high voltage stuff, the equipment that we would come to. So we have 3 different classifications of voltage at a mine, and just going back over these 3 questions. Low voltage is from 0 to 660, medium voltage is 661 to 1000, and high voltage is more than 1,000 volts. And someone told me that's questions on the test, and they ask that all in one question. So I don't know for sure how they do that, but you do need to know the classification of the voltages. Number 8, how are high voltage cables required to be installed along haulage ways? And the answer is in regularly inspected airways, placed to afford protection from damage, guarded where people pass under or over them unless placed 6 1/2 feet or more above the ground or rail, anchored properly, insulated, guarded at the ends, and placed to prevent contact with trolley wires and other low voltage circuits. So that's a lot of information there in that question. Someone told me on the test that the question is asked, how far do they have to be above the ground to not be guarded? And that's 6 1/2 feet. If they're 6 1/2 feet or more above the rail or ground, they would not have to be guarded. Again, most people probably guard their high line everywhere, but for the question on the test, I think the 6 1/2 feet is important. Number 9, cables that enter metal frames of motors, splice boxes, and electrical compartment shall be provided with, and that's proper fittings. So anytime a cable enters a box, if you could just imagine we have this metal enclosure, so we cut a hole in it to get a cable into it. We know it could have sharp edges on it, so we have to protect that cable with proper fittings. And if it is a permissible enclosure, then it would have to have a permissible fitting or entrance gland into the box. 10, how do you identify permissible equipment? And the answer is the equipment will have a U.S. Bureau of Mines or MSHA approval plate. So all permissible equipment is identified with an approval plate. So I could come to your mine and you could say, hey, go in the shop and find us a permissible motor. And I could do that by looking at the motors and finding the ones with the tags on them. I would know that if it had that tag, it would be permissible. If it don't have the tag, it's not permissible. 11, the maximum separation of a plain flange joint to maintain permissibility is, and that's 0.004 of an inch. And here's a little picture. So here I have an enclosure, and this is a plain flange where the lid just bolts onto the enclosure, and 0.004 of an inch is the biggest gap that you can have here. And the purpose for that is you could have arcs and sparks within this enclosure. There's a lot of electrical connections being made in there, and it could arc and spark, and you could actually have an explosion in there. But the heat that's created within that enclosure, by the time it reaches the outside, because it has to travel this tight gap of 0.004 of an inch, will cool it down. Will cool that heat down before reaching the outside, so that it will not be hot enough to cause a methane gas explosion on the outside. And that's part of maintaining permissibility. It's designed that way. It's designed to have that small 0.004 of an inch gap, so things will be cooled down before reaching the outside. 12, what happens to motors that are exposed to undervoltage or continued overload? And the answer is heating will destroy the insulation. 13, when is an electrical enclosure or device considered explosion proof? And the answer is when the enclosure or device is designed so that any explosion occurring within the device will be cooled before reaching the outside atmosphere, so there will be no ignition of a surrounding mixture. So we just talked about that. We have 0.004 of an inch gap. That's the maximum size we can have to make this an explosion proof enclosure. Again, it will not cause an explosion. If you do have an explosion within the device, it will be cooled before reaching the outside, so there can be no ignition of a surrounding mixture. Someone told me they asked that on the test. They kind of reversed that. They kind of want to know the definition of an explosion-proof enclosure, so make sure you understand that both ways. Either way, they could ask it. And here's the little picture again. The heat from the arcs or sparks will cool when it passes through the tight enclosure and will not ignite any gas on the outside. 14, who can do electrical work in a mine? And the answer is certified electricians or apprentice electricians. And the apprentice electrician must be working under the supervision of a certified electrician. So this is the only people that can do electrical work, either a certified electrician or an apprentice. And an apprentice electrician is a person that holds a card that certifies them as an apprentice electrician. 15, at what voltage does trailing cables that are not on cable reels require grounded metallic shielding? And that's at 661 volts, which is medium voltage. So your cable going to your continuous miner is probably 995 volts, and it has to have metallic shielding tape around the phases. And for medium voltage equipment, this is a safety feature in the cable, because if this cable would get a hole in it and somebody run over it or whatever, that electricity from that phase will encounter that metallic shielding before it can reach the outside. And when that voltage encounters that metallic shielding, a breaker will kick. So that's a very good safety feature for medium voltage cables. 16, what protective device is installed on all ungrounded exposed power conductors that lead underground? And the answer is properly grounded lightning arresters. 17, how far out by the last open crosscut must transformers and trolley feeder wires be located? And the trolley and the trolley feeder wire is just a wire coming off the trolley wire, and these are not permissible. All these items are not permissible, so they have to be at least 15 feet out by the last open crosscut. 18, how far out by pillar workings must transformers and trolley feeder wires be located? And the answer to that is at least 150 feet. So it has to be back much further from pillar workings. And I've worked pillaring a little bit, and you really have to stay on top of this, because as you're moving back, you can get too close to your power center, and it has to be at least 150 feet out by the pillar workings. 19, how often must electrical equipment be tested? And that is monthly. So electrical equipment has to be tested monthly, and these tests are determined to determine if a breaker will kick under fault conditions. So this is a pretty big deal, and this is done monthly. 20, how often shall electrical equipment be examined? And the answer to that is weekly. So we examine it weekly for permissibility. So an electrician will be assigned a piece of equipment. He'll have a book of things that he's supposed to check, and when he checks it, he'll check off the stuff, and anything that he finds wrong, he will fix. So electrical equipment is examined weekly and tested monthly, and I believe that question will be combined on the test. Again, it's a little bit confusing. Try to remember examined weekly, tested monthly. 21, what is an apprentice electrician? And the answer to that is a person that holds an apprentice electrician card, is in training to perform work on electrical circuits and electrical equipment. So to be an apprentice electrician, you have to have at least an 8-hour hazards of electricity class from an approved instructor. Your name would be sent to the West Virginia Office of Miner Self-Safety and Training, and then they would issue you an apprentice electrician card. And you're supposed to be working at a company that has an approved apprentice electrician program for you to get your time to be able to take the electrician's test. But to be an apprentice electrician, that is a state certification, and you will have a card that indicates that you are an apprentice electrician. 22, what type of gloves should be worn when troubleshooting and testing energized electrical equipment? And the answer to that is gloves rated for the maximum voltage of the equipment being tested. Again, you're not allowed to work on energized equipment. You can only troubleshoot and test. So you wear the gloves rated for the maximum voltage that you would encounter. You troubleshoot and test, and as soon as you determine what's wrong with the piece of equipment, you should de-energize, lock and tag it out, and make your repairs. 23, Where are ground fault circuit interrupters required? And the answer is when using 120 volt electrically operated hand tools, and this is usually required in wet locations. So, wet locations at prep plants, surface areas of underground mines, concrete slabs in contact with the earth. There's lots of definitions of where this is required, but the 120 volt electrically operated hand tools in wet locations. And you have ground fault circuit interrupters at your house, in your bathrooms, in your kitchen, maybe outside. You have ground fault circuit interrupters. Again, 120 volt electrical circuits have GFCI. 24. Where shall the trolley wire be located with respect to the rail? And the answer is at least 6 inches outside the track gauge on one side only. 25. Why is the trolley wire located outside the track gauge? And the answer is to protect the equipment operator from coming into contact with the trolley wire. I've been told that these questions are combined on the test, that the trolley wire is 6 inches outside the track gauge to protect the equipment operator. And here we have a little picture of showing if you can see my pointer, the rail here, and just imagine we project a line straight up to the roof, and at that point the trolley wire, which is the red ball, would be located at least 6 inches outside the track gauge. And again, if you can see my pointer floating around here, the equipment operator would be inside that somewhere, so he's never going to come into contact with the trolley wire. 26. Where shall trolley wire and trolley feeder wires be provided with cutout switches? And the answer is intervals not to exceed 2,000 feet and at the beginning of all branch lines. So a cutout switch on the trolley wire every 2,000 feet, and where it branches off to go to another section at the beginning of that branch line. 27. Where shall trolley hangers be installed in reference to a trolley wire splice? And the answer to that is within 3 feet on both sides of the splice. 28. What shall be provided on each phase of an underground high voltage cable? And the answer is metallic shielding tape around each phase. Now we talked about the medium voltage has the shielding tape around it for a safety feature. On high voltage, it's certainly a safety feature, but another thing it does is high voltage kind of does weird stuff. And you'll actually have a force field around that cable, and this shielding tape blocks that force field. I think if you don't have that metallic shielding tape around the high voltage cable, that electric force field will eventually destroy the insulation on that cable. So the metallic shielding tape on the high voltage cable is a safety feature as well as protects the insulation of the cable. 29. How shall telephone lines be installed? And that's on insulators opposite the trolley wire and high voltage cable. 30. What distance shall telephone wires be maintained from other power wires? And that's at least 12 inches. 31. How shall surface transformers be installed? And the answer is installed on a platform at least 8 feet above the ground, or if placed on the ground, they must be surrounded by a fence at least 6 feet high. The enclosure should be grounded. So someone's told me this question is definitely on the test, and what they're looking for is the numbers. So if I have a surface transformer, I basically have a choice. I can put it on a platform that's 8 feet or more above the ground, and that's good. No one can get to it. No one can come in contact with it. If I choose to put it on the ground, and most of them I've seen are on the ground, then what I have to do is put a 6 foot high fence around it to keep people from going into that area. And the closure should be grounded if it's metal. 32. What must be done before work is performed within the cargo space of crusher or feeder? And the answer is the crusher or feeder must be de-energized and locked out. So we always talk about electrical equipment being locked and tagged out, and that's absolutely true. We lock and tag out every piece of electrical equipment if we're going to be working on the circuit. But also, we should lock and tag out anything that unexpected motion could injure you. So, if you're going to splice a belt, that belt needs to be locked and tagged out. If that would come on when you was making the splice, you could be injured. So certainly when you were working in the cargo space of a crusher or feeder, that would be de-energized and locked and tagged out for your safety. 33, what is a fail-safe ground monitor? And the answer is a device that continuously monitors the grounding conductors to assure continuity. If the ground wire or pilot check wire is broken, continuity is lost and the circuit breaking device will be open. So our very first question talked about a ground and kind of talked about how important it is to have that. So what we do is we actually monitor that ground. So we have here in my little picture, it's coming from the power center, and the green lines here represent a ground wire. And then we have a monitor wire that I have represented as yellow. And we actually have an electrical circuit flowing through that. And it could be 24 to 32 volts. And if either the ground wire or the pilot check wire breaks, then the circuit breaker will trip. This is to make sure the ground wire isn't broken. So again, this is we have electrical flow through the ground wire to the monitor. This is a complete circuit, and this circuit holds the breaker in. And we have energized equipment. We can work, we can mine, we can roof bolt or whatever. But if the ground wire would get broke or the monitor wire would get broke, then the holding circuit would drop out and the breaker would kick. Very good safety device. Make sure you always have a ground. 34, what must all battery-powered equipment be provided with? And the answer is an undervoltage indicator, which will indicate when the voltage is less than 3/4 of its rated capacity. So most scoops or battery-powered equipment has a gauge or a light bar that will warn you when it's less than 3/4 of the rated capacity of the batteries. So give you a heads up and go change the batteries. 35, all equipment of the same manufacturer and model shall have, and the answer is controls that have the same direction of activation and direction of operation. So if you run a so-and-so type roof bolter at one company and you go to another one and they have that same model and manufacturer, the controls should do exactly the same thing. 36, power lines constructed over haulage roads must be constructed to provide a minimum clearance of, and the answer is 12 feet above all equipment used on the haulage road. And this includes dump trucks with the bed in a raised position. So if we have power lines going over haulage roads, they have to be a certain height so we don't get into them with equipment. And we want to maintain 12 feet above all equipment being operated on that haulage road. And we want to maintain 12 feet if we had a truck with the bed raised up. We want to maintain 12 feet above that. 37, what's a panic bar? And that's the answer is a device, a safety device that will quickly de-energize the equipment in the event of an emergency. 38, what's the definition of electrical work? And the answer is electrical work shall mean work consisting primarily of electrical construction, installation, testing, inspection, maintenance, and repair tasks on electrical coal mine equipment, apparatuses, circuits, and or distribution circuits used in or around a coal mine. So a lot of times we say, a certified electrician or an apprentice is the only people that can do electrical work. So that definition of electrical work can be very important. So very important to know who can do this work. 39, the term work area is related to an apprentice electrician working under the direct supervision of a certified electrician means. And the answer is the work area means within 500 feet in any direction of the area in a mine where electrical work is being performed. So the work area, as defined, is within 500 feet. 40. Define direct supervision as it pertains to an apprentice electrician working under the direct supervision of a certified electrician. And the answer is the direct supervision means both the electrician and the apprentice are in the work area. And from the previous statement, the work area is within 500 feet. So if a certified electrician has an apprentice working under their direct supervision, then that means that they're in the work area, which is within 500 feet. Question 41. Define immediate supervision as it pertains to an apprentice electrician working under the immediate supervision of a certified electrician. And the answer is immediate supervision means the physical presence. The certified electrician and the apprentice are side by side. Someone told me these questions are combined on the test. So they ask you to define both of them. So the immediate supervision means the physical presence, and direct supervision means in the work area within 500 feet. That's the end of this video. Thank you.